Hello geometry students, Mr. Cazzato here, and today's question of interest is given three parts of a triangle, will you always make congruent triangles? What I mean by that, let's suppose we're manufacturing trusses that go up in the attic and you're given three sides. If the west coast is making triangular truss given three sides and the east coast is making triangular trusses that go in the attic with three sides, and then we ship them to the Midwest here in Chicago, will they be the same? So we call that side, side, side. So if I give you three sides, will we all make the same triangle is the question of interest. So let's take a look at this visually. On the left-hand side, we have a triangle with sides A, B, and C. You can see the different tick marks. And I'm going to grab this slider and I'm going to slide side C. I'm going to slide side A and then side B. And if you notice, these two triangles are congruent. So the main idea here is no matter what, if I give you three sides of a triangle, you will always make congruent triangles. So going back to this notes page here, this is just going to be a summary, and eventually we'll get to the notes packet, pages 21 to 23. If I give you three sides of a triangle, you will always make congruent triangles. So I'll just put a check mark there, or maybe I'll even put yes. All right, so what else can we give you? Well, we could give you three angles. If I give you three angles, will you always make the same triangle? So here on the screen, you can see the red angles are the same, the green angles are the same, and the blue angles are the same. And if I were to drag the triangle here, notice the angles are still congruent, but the triangles are not. If you think about a photograph or a photocopy machine, or your pictures that you get for school, you have 8x10s, you have 3x5s, you have wallet size. The angles are all the same, the picture is not distorted, but the triangles are not congruent. If you look at the screen, here we have three angles, triangle ABC and triangle DEF. You can see the red angles, the green angles, and the blue angles are congruent. But the triangles are not congruent. They are different sizes. No matter what I do here, the angles are identical, but the triangles are not congruent. So angle, angle, angle does not justify congruent triangles. If you think about your yearbook pictures, you have small wallet size, you have 3x5s, you have 8x10s. Your picture is the same, but the photographs are not the same size. So looking at this page here, does angle, angle, angle justify congruent triangles? No, they do not. So I'm going to write no. So what else can you be given? So I always want to give you three pieces of information. So you could be given two angles and a side. So I could give you two angles and a side. So what if I were to give you, and I'm going to write this down, angle, side, angle. Now in geometry there is also another one called angle, angle, side. I'm going to explain the difference between these two. So you're given two angles and a side. Let's see what happens. So on the screen, this is an example of angle, side, angle. Notice the side is between the red angle and the blue angle. That's going to be different than angle, angle, side. So what you see on the screen is called angle, side, angle. The side is between the two angles. So I'm going to grab this slider and I'm going to drag angle A over here. Then I'm going to drag the side there, rotate it a little bit, and then the angle here. And if you notice, those two triangles are congruent. So if I were to go backwards here, just real quick. So angle, side, angle, copy the angle, copy the side, copy the angle. Notice you will get congruent triangles. Even if I change the shape or the size of the triangle, you will always get congruent triangles. So going back to our notes page, angle, side, angle, that works. So I'm going to put a yes there. Now I'm going to compare that to angle, angle, side. So remember on angle, side, angle, this first one, the side was between the two angles. So let's take a look at angle, angle, side. So on the screen here we have an example of angle, angle, side. We have the blue angle, we have the red angle, and then we have the blue side. Notice the blue side with the tick mark is not between the two angles. So angle, angle, side is different than angle, side, angle, which I showed you previously. Notice the two triangles are congruent. Even if I were to change the size of the side, those two triangles are congruent. If I were to change the angle, those two triangles are congruent no matter what. So angle, angle, side is a way to justify congruent triangles. So going back to this page, does angle, angle, side work? Yes. Now for clarity, for angle, angle, side, the side is not between the two angles. And I'm going to draw an example of angle, side, angle, and angle, angle, side, since that tends to be the confusing part for some students. So we have one angle, we have a second angle, and then we have a side. So this is the picture for angle, angle, side. In contrast, we have an angle, a side, and an angle. The picture on the right is angle, side, angle. Notice this side is not between the two angles in the yellow, but the green side is between two angles. So this is angle, side, angle, and the picture in the middle is angle, angle, side. So let's do just a quick little summary. Side, side, side works. Angle, side, angle works. Angle, angle, side worked. But angle, angle, angle did not work. So what are some other possibilities? I could give you two sides and an angle. And just like in the last example, there are two possibilities here. We could be giving you side, angle, side. So in this example, I'm going to draw this picture here. The side and another side, the angle is between the two sides. So here the angle is between the two sides. So let's take a look at a visual of this one. So on the screen we have a picture of side, angle, side. Notice the red angle is between the two sides with the tick marks. And let's see what happens here. I'm going to copy the first side. I'm going to copy the angle on the third side. And then if you notice the triangle there, when we moved it, it was the same exact triangle. So I'm going to repeat that just so you see it one more time. So copying the side, copying the angle on the side, and then the triangles are congruent. So moving back to this page here, side, angle, side does justify congruent triangles. All right, another possibility is you could have side, side, angle. So here, the angle is not between the two sides. So a picture for this particular problem. So we have a side, another side, and then we have the angle. So this is an example of side, side, angle. In the top picture, we have side, angle, side. In the blue picture at the bottom, we have side, side, angle. So let's take a look to see if side, side, angle will justify congruent triangle. So on the screen, you have an angle of 35 degrees, a side of 6, and a side of 3.7. And so this is an example of angle, side, side. So the angle is not between the two sides. And I'm going to move this side 3.7. Notice I get a triangle there. But if I were to move it a little bit further, I get a second triangle. So for angle, side, side, it's possible you get this green angle, or excuse me, green triangle, or it's possible you get the off yellow or off white triangle. So if you have angle, side, side, you get two different triangles. Therefore, angle, side, side is not a method to justify congruent triangles. So coming back to this page here, side, side, angle does not work. So I'm going to put a big X through this one. Side, side, angle does not justify congruent triangles. If you're to read it backwards, angle, side, side is a bad word. We don't use it in school. Therefore, we cannot use it to justify congruent triangles. Okay, another possible way to justify congruent triangles is when you're given a right triangle, and I want to go through some vocabulary. So if you look at this picture here, this yellow side, we have a yellow side and a right triangle, we have a green side and a blue side. Okay. The yellow and the blue are called legs. So those are called legs. And across from the 90-degree angle, the green side is always called the hypotenuse. I'm going to abbreviate it hypotenuse. So a third possibility works a fifth possibility works when you're given a right triangle. So let's take a look at another example of justifying congruent triangles. But this only works in right triangles. So if we take a look at the screen, we have a right triangle. The purple side is called the hypotenuse, and the black side is called the leg. So I'm going to drag the hypotenuse, drag the leg, and notice here, those two triangles are congruent. So this is a special case called hypotenuse leg. So if you have a hypotenuse and a leg, the purple and the black side, and you were to copy that right triangle with that hypotenuse and leg, you always will make congruent triangles. And I'm just going to change the size of the triangle so you can see that. I also could rotate it a little bit. So a fifth way to justify congruent triangles is called hypotenuse leg. So hypotenuse leg is the fifth way to justify congruent triangles. And this is the typical picture you might see. You're going to see a tick mark on the hypotenuse and a tick mark on the leg. So just to summarize, there are 5 ways to justify congruent triangles. They are side, 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 angle, side, angle, 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 side, side, angle, side, and hypotenuse leg. So these are the 5 ways to justify congruent triangles. And just for completeness of your notes, angle, 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 and side, side, angle do not work. So these methods do not work. This should help you better understand pages 21 to 23 in our notes packet.